Alright guys, welcome to the 23rd video of the Java game development series, and today we are going to continue the development of our infinite jumper. So let's see what we have got right now. And it's still called Blackpoint even though it's not anymore, but who cares, we did the menus and they're fine like that. And yeah, right now we have this guy jumping infinitely, and don't wonder why he's like going into the ground, because the ground is actually not there. He starts at such a high position that the camera is already set a little bit above the ground. So what we want to do today is, at first you're gonna notice that last time we put these walls there, but it's actually cooler if we go to the side that he just comes out of the right side again. If we go to the left side, and if we go to the right side, he comes out of the left side again. Like, that's what most infinite jumpers do. Also, as you just noticed, he doesn't jump up anymore. Why is that? Well, that's because if we do... Oh, he's actually jumping up. But as you can see, he's not jumping up as high anymore. And that's some kind of bug, because right now we are just using the restitution to let the player jump. But the restitution is essentially he jumps up as much as he fell down. But if he doesn't fall down as much, he also doesn't jump up as much as in the previous jump. So if we would like jump on a platform from here to here, the distance between the highest point in the jump and the platform is definitely less than the distance between the highest point in the jump and the ground. So he would just jump up like this little. And also you see this kind of bug there, I don't know what this is. He keeps jumping higher. So that's one thing that we want to fix today by not just using the restitution. Also, I don't know in which order we are going to do this or whatever, but if we have enough time, we want to make some one-sided platforms. So a platform that we can jump through from coming from under it, and if we fall down on it, we can just jump on it and not pass through it. So these are pretty much the very initial steps to create an infinite jumper, and let's get started before I talk too much. So it's 1:24 now. Let's see how much time we take to do this. So the first thing that we want to do is that we want to go to the player class. And no, let me think. Okay, let's actually start with making the player come out of the one side and go to the other side. So right now we have this chain shape set up to build some walls right here. But we don't need this anymore, because the chain shape is just supposed to be the ground, so he can initially jump and then jump on the platforms. So we don't need the up right and up left vectors anymore, because we just need the bottom. We don't need any walls there. So these can go, and up left can all go, as well as up right. And we should be good to go. I just said go 3 times. But anyway, let's see what is the result of this. And yeah, there's the platform, but no walls anymore. Of course, this is not really an improvement right now. Whoop, and he's gone. Okay, so now we want to have this going to the other side. And that's pretty simple to do. We just want to do this, let's say we want to do it in the play screen, not in the player itself. I don't know what's the best object-oriented way to do it, but we are going to do this in play screen. So at first, the bot left and bot right are not going to be declared in here. They are going to be declared up, all the way up here in the class. So let's put them like there. And also, since we can just call them bottom, let's do it. This refactoring, what is your problem? This refactoring can be performed due to syntax errors in the compilation unit. Fuck you. What syntax errors do we got here? Alright. we have to put a semicolon there. That was stupid. Alright, so we want this to be bottom right and bottom left. Yes, I know, god damn it. Alright, so we finally did it. Now up to the for the render method, we have to check if the player reached the left or the right side and move it to the other one. So to do that, we are going to use these bottom left and bottom right points, because they are the camera's, yeah, they are like what we used to create the world previously, so we can use them to have these invisible bounds now. Let's go to the render method, and we do this before player.update, because yeah, we want to have the player in the correct position previously before we update. For this, we are just going to use a simple if and say if player.getBody.getPosition.x, because we don't care about the y in this case, is smaller than bottom left.x. So if it's more to the left side than the left side of the screen, then we want to put the player to the right side. Now this is box2D, and it basically takes care of putting things into certain positions itself. So how do we put the player somewhere? I thought we didn't have to do that. Well, we can do it using player.getBody, so set transform. And yeah, as the name says, transform can transform various things of this player. And we are going to use bottom right, because we want it to right side, .x, and the y should stay the exact same. So player.getBody.getPosition.y. Now for the angle, and since the player doesn't rotate at all, we could just say 0, and who cares, but just for the future, I don't know if we want to make him rotate or whatever, I'm going to say player.getTransform, because at first I have to get the body, and then get angle. Get angle is fine. We could also say getTransform.getRotation, but get angle is actually better. So alright, we got this line here that puts the player on the other side of the screen. Right now we're just doing this if the player crosses the left border of the screen, but we also want to put him to the left if he crosses over the right. So I guess you can think of what's going to happen right now. Else if player.getBody.getPosition.x is bigger than bottom right.x, then player.getBody.setTransform bottom left.x, player.getBody.getPosition.y, and player.getBody.getAngle. Alright, a lot of gets there. And let's hope this works fine, because I actually didn't try it this much before, just a little bit. And we're going to jump to the left, and he comes out of the right, like magically. That's awesome. Perfect. Okay, so what do we want to do next? We want to... yeah, let's actually start by putting a platform there, because we are going to need this for testing or whatever. So let's go into the show method, and just here under creating the ground, after that we're going to create some testing platform. Of course, this is not going to be the way we are going to create the actual platforms later, because that's crazy. But we want to make the ground shape a new shape. Chain shape. You cannot call just ground shape.create chain again. I tried it and it kind of doesn't work at all. So ground shape.create chain after creating a new ground shape in the ground shape, and this is going to take into float. Hooray! And let's say we want the platform at bottom left dot x. Nope. Bottom right dot x divided by 5. So that's where it starts, like 1/5 of the screen. on the left or something. Y is going to be, I have no idea, seriously. We could unproject again, but this is just a testing platform, so let's just figure out some values. Let's see what the player is like this big, and then if you put some players on this guy, it's probably like 10 meters or something. Going to bottom right dot x divided by 4 and 10 meters again. So let's hope I figured that out correctly. And oh, I'm stupid. We still have to create this ground shape. So world.create body definition dot create fixture. Ground shape density doesn't matter, it's a static body. It's still static from before, so we didn't have to set that. Let's see if I messed it up. Well, that's a pretty small platform. Seriously. So let's say, I don't know, divide by 10, yeah, okay. How that looks. Well, okay, that's a little bit more realistic, but still pretty far up, so I'm going to put that at 8 or something. It's still over the player's jumping height or whatever. Let's just put it at 6. So after watching me create this testing platform for like 3 minutes, we finally have it, and it's still a little bit too high. The player can reach it. Ah, crap. So 5 meters, and now the player should be able to reach it. Okay. So the problem is that the player just bounces off it. If we normally jump on a platform, we would like to pass through it from below and then jump on it and continue. So we kind of have to see if the player is coming from below and let him pass through. So we can do this using a contact filter. Let's actually do this in the player, because the player filters the contacts for this kind of contact. So we want to implement the contact filter. Of course, we have to import this thing and add the unimplemented methods. This gives us the should collide method here, and I'm just going to put this over the getters and under the update method. That's just fine. So please take me there. Thanks. Alright, so this should collide method gives us 2 arguments, and those are the fixtures that are about to collide or colliding or whatever, and then we just return if it should collide or not. So we can at first check if this has anything to do with this, because there might be other collisions in the game. I mean, in this game it's not very likely, but there might be other collisions going on in the game that we don't want to filter. So let's say if fixture A equals fixture, and remember, fixture is that thing that we have up here just to be able to assess it easier. Or if fixture B equals fixture, then we want to see if fixture, because we know that fixture A or fixture B is the fixture of this one, so we can just say fixture. And actually we don't even want the fixture, we want the body, okay? And get the linear velocity from it, so the movement, it's the direction, the movement, the force, everything. Take the y component and see if it is greater than 0. So if he is moving on y more than 0, so if he's moving up, that was a pretty shit explanation. But anyway, if the movement force on the y-axis is greater than 0, that means he's moving up. In this case, we don't want to collide, so return false. We can actually simplify this by just returning this. If it is moving up, but actually we want to have this the other way around, because we want to return false in that case. I hope I didn't mess that up again. And we get some hotcode replace failed. And we still have to put this into the world somehow. Just by implementing this method, nothing really happens, it's never called. So let's go to the play screen, and right after creating the player, right there, we want to tell the world that this guy is a contact filter. So set the contact filter to the player. He now takes care of filtering all the collisions. And after loading up, play, and let's see if it works. Yeah! Well, okay, the player doesn't quite jump up to the actual top of the platform, but you can see that he's kind of passing through. Actually, let's just get the platform down a little bit more, like to 4 meters, and then we could actually jump on it. I hope, but I think this is still not enough. Ah, well, okay. And now you see the next problem. Once he jumped on it, at first it kind of bugs around because he keeps jumping higher and higher, but he actually shouldn't. Second thing is, with this kind of jumping height, we're not going to reach the next platform that's somewhere up here or up there. We want the same jumping height as this one here. This jumping up pretty far, but this, what the fuck is that? And that's the main thing that we're going to take care about in this video, because it's the most important one. And that's also happening in the player. And we want to implement another interface for that, called the contact listener. Import, and there we go. So what does the contact listener do? It gives us this method. What kind of method is that? I forgot its name. Great. So let's see if we can override that one from the contact listener. Alright. It gives us 4 methods actually, and I don't want this documentation. Alright, so it gives us 4 methods. The first one is begin contact, then end contact, pre-solve, and post-solve. This is actually not the order they're called in, so let me just sort them real quick. At first begin contact is called, then pre-solve is called, then post-solve is called, and then end contact is called. So what are they all doing? We might hover over them and we see that begin contact is called when 2 fixtures begin to touch, which means they begin to touch. They do not touch yet. That's very important. Imagine these 2 fixtures shapes coming through each other, to each other, and when they overlap, this method is called, but nothing yet happens. Usually when they overlap, they should collide and go into opposite directions, and this is going to happen. But this is happening right here. I can actually put a comment there saying collision calculating stuff. Okay, so this is where it's actually colliding. And in begin contact, it's just saying they are beginning to touch each other. I can't talk today again. They are beginning to touch each other. We don't need this method today. Pre-solve gives us one more thing here. The manifold that contains whatever kind of information about the contact and stuff. We don't need it. Then we have the post-solve method, which is what we're going to use today. And yeah, they are pretty self-explanatory. This could actually be called solve. So yeah. And then end contact when they are not touching each other anymore. So let's actually have some kind of visualization by just printing out the names to the console and make sure that they're actually in the right order. Pre-solve, post-solve, end contact. So I just want to make sure I don't talk crap here. Restart. And this should just print out these 4 method names in exactly this order. So let's go play and watch the console. And nothing is happening because we didn't put the player into the world's contact listener yet. Just like world.set contact filter, we have to say world.set contact listener, and since the player implemented that thing, we can just put him in here and we're good to go. So we need to restart this, and now we should see something in the console, which is, if we kill this quickly, begin contact, pre-solve, post-solve, end contact. Begin contact, pre-solve, post-solve, end contact. Perfect. So now let's remove these guys here and actually get to the implementation of this jumping kind of fix. So we want to go into the post-solve method, and we want to say, okay, let me just start that up again. Start up, come on. Play. Alright. So we want to say, crap. I want this to be a good example, okay? So please get on there. God damn it. Get on there. What is that? Come on. Okay, fuck it. We want to say, in post-solve, we want to take care of the power that he jumps up with again ourselves. We don't want Box2D to do this. What we want Box2D to do though is to apply the friction, okay, and the restitution as well. So the restitution is going to be set to 0 because we are going to take care of this ourselves, but the friction can just stay as it is. Whatever value you set this to, it's fine. The friction and the restitution are computed in the solve thing that Box2D does, which is happening right here, and this means that in the post-solve method this has already been done, which means if we have a high friction, the body is going to has already been decelerated at this point in the post-solve method. In the pre-solve method, the body has not been decelerated yet, but we want it to do these calculations before we take care of jumping, so we go into the post-solve method. Not into the end contact, because the contact is not ended yet. This is called when the two fixtures do not touch anymore. Like we can say, called when two fixtures cease to touch. But the post-solve one is like the step in between. We calculated stuff, but they are still touching each other. Okay, so let's say, at first we have to check if this contact has anything to do with us in the first place. So contact.get fixture A, if that equals our fixture, or it may also be fixture B, then alright, then we want to apply an impulse on that body to push him up. So the jumping is basically applying an impulse, which probably makes sense to you. So we're going to take the body and apply a linear impulse on that one. No impulse on the x-axis, some impulse on the y-axis. What impulse is that going to be? I'm just going to say 65 for now, but that's going to turn into a variable later. Point x is the point on which we want to apply this impulse. We have to give this in world coordinates again, so we have to kind of get the body's local position or something in world coordinates. We are lucky and there is this world.getWorldCenter, which just returns the center of mass, which is usually in the center of the body and definitely in the body. So get world center, and we have to take the y and x coordinates of it, and we want to wake the body up if he's sleeping, which is probably not going to be the case ever. But anyway, we are applying an impulse, no impulse on the x-axis, some impulse on the y-axis, onto the center of the body, which we get by get world center, which pretty much says get the center of the body in world coordinates. So alright, let's try this out. And remember, we have 0 restitution here, and nevertheless he's jumping. Alright, so now this is what I've been talking about in the beginning of this video. That is the point that he jumps to. So that is the point where he begins to fall down, which means he falls from here to the ground, so he jumps back up to here. But if we were to jump on the platform, he falls from there onto the platform, and nevertheless jumps up the same height, because of our applying an impulse. If we didn't do this, he would just jump this little distance that he fell down up again. So now let's just go ahead and turn this into a variable, like jump power or something, and put that up here to the floats. Movement force, jump power, because we definitely can't take the movement force, that's way too hard, way too much. And actually, let's say the jump power, I mean, he's jumping up pretty high right now. 65 is something heavy. Let's say 45, that's probably better. Yeah, come on, restart. And play. And there we go. He's not going to reach the platform now, but as you can see, he's jumping. He's going through the walls, and he's taking care of his restitution. No, of his friction. We can also set the restitution to 1, which would give him a pretty heavy boost, and we have to restart the screen for that. So this means he jumps up to the height he fell down, and then on top of that we apply this force. So he keeps jumping higher and higher. You could use this for some kind of bonuses in the game, like you pick up the fruit of awesomeness and you're jumping awesome. Okay, also I just really quick want to put the player on 3 meters initially, so the camera actually starts on the ground, which is not happening at all right now. Let's say the player is at 2 meters. That can be. Well, it obviously can. That is weird, but whatever. Okay, so anyway, I hope you learned something from this episode and also enjoyed it a little bit. That would be nice. If you did, I'm happy to see you in the next video, and have fun developing your games, whatever. Yeah, see you in the next video.